Today we have to discuss about interference in thin films. Okay, so interference on thin films. Thin films is nothing but you have to consider a very thin transparent material or thin transparent media. So that media you have to call it as a thin film. So this interference phenomena is observed in a thin films by two scientists. So first one is Newton and second one Hooks. Okay, these two scientists observed the interference phenomena in thin films. Okay, this interference phenomena will be observed by these two scientists due to the multifold reflection of light on the surface of thin film. So multifold reflection, due to the multifold reflection, the interference phenomena will be formed. Okay, generally we the beautiful colors produced by the thin films. So generally beautiful colors will be produced by the thin films. Generally you know that if you take a drop of oil on the surface of water, at that time you have to observe the interference pattern on the oil. It means the different colors or rainbow colors will be observed on the droplet of the oil. So for example, if you have to consider a soap bubble on the water, soap water. So if you observe the soap bubble, at that time you have to observe the interference pattern on this soap bubble. Means the different rainbow colors will be formed. Okay, generally these two scientists, mainly Hooks, he observed such colors in the thin films. Hooks observed such colors in thin films like mica. Mica, it is a substance or a material made up of a glass. And another one scientist, Newton, he observed an interference pattern when a convex lens was placed on a plain glass plate. Okay, so the Newton observed, he take one thin glass plate, he kept a plain or convex lens on this glass plate. At that time he observed the interference pattern or bright and dark fringes. Using a telescope he observed the interference patterns. This one by the Newton, and Hooks observed directly different colors on the thin films like a mica glass. So interference in thin films takes place due to the interference in thin films takes place due to one is the reflected light and another one is the transmitted light. So already we discussed about the reflected light, and now we have to discuss about the transmitted light. Okay, now interference in thin film due to transmitted light. So interference, we have to observe the interference phenomena in thin film due to transmitted light. So here we consider a thin film, okay, transparent thin film having a thickness T. This thin film having a thickness T and having its refractive index N. So now we have to incident a ray of light on this thin film surface, the path AB, and this ray will be refracted towards C and it takes a path BC. So So the angle of incidence you have to take it as I, angle of refraction you have to take it as R. So this refracted ray, again it will be reflected back from the point C. Okay, it will be reflected back along the path CD. Okay, and the one ray will be transmitted. So the transmitted ray you have to take it as CR. So this reflected ray again it will be reflected D and it will be transmitted or refracted along ER. Okay, so here we got the two transmitted rays. So using this transmitted rays, you have to find the optical path difference between these two rays. Okay, first we have to draw a CN, it is normal to the D, and EN, it is normal to the CN. Okay, these two are normals we drawn, and we are drawing these normals because we are finding the optical path difference between the CR and EQ. Okay, now we are finding the path difference between these two lines. Okay, here the all reflection will be takes place from the rarer medium, here also rarer medium, and the reflection will be takes place from rarer medium. At that time there is no phase difference in the light. When the rays the reflected rays from the denser medium, at that time there is a phase difference phi. Okay, we consider a phase difference the interference in thin film due to reflected light. Here transmitted light there is a no phase difference. So now we have to take the path difference. So the path difference you have to take it as a x equal to n is the refractive index, and the CD here CD plus DE the path, the reflected path, and minus CN. So minus CN. So minus CN. So now also we have to take n equal to sin I divided by sin I. So n equal to sin I divided by sin I, we know that this is the Snell's law for refractive index. So here you have to take sin I, this is the angle R, this is the angle R. So sin I you have to take it as this is the angle R, this is the angle R. So sin I you have to take Cn, and sin R you got the ME. Okay, so or Cn equal to, you send this ME on this side, so Cn equal to ME dot N. Okay, now in figure, so triangle CPD, so triangle CPD, so here we drawn a normal and we have to emerge the D ray towards the point P. Okay, at this point the interference pattern will be formed. So from the triangle CPD, so this is the angle of refraction, so equal to R, and here DP and CD, DP, CD and DE, all these rays are equal. This one and this one, this one, all these rays are equal. So therefore CD plus D, CD plus DE is equal to the P. So this and this is equal to this and this. So CD plus DE is equal to the PE. Okay, I written it. So therefore X equal to N dot P. So N dot P, because here CD plus DE equal to P. So I put the P value here. So N dot P minus Cn value here you got ME dot N. So N dot ME equal to, so N into N is common on this, so take a N outside, so remaining term P minus ME equal to M dot PM. So P minus ME, here you have to observe PE minus ME. ಈ ಪಿ ಎ ಒಳಗೆ ಮೈನಸ್ ಎಮ್ ಎ ಮಾಡಿರೋದು ರಿಮೈನಿಂಗ್ ಪಿ ಎಮ್ ಸೊ ಅದನ್ನ ಪಿ ಎಮ್ ಇಲ್ಲಿ ತೊಗೊಂಡು ಎನ್ ಡಾಟ್ ಪಿ ಎಮ್. ಸೊ ಇನ್ ದ ಟ್ರಯಾಂಗಲ್ ಸಿ ಪಿ ಎಮ್, ಸೊ ನಾವು ಯು ಹ್ಯಾವ್ ಟು ಟೇಕ್ in the triangle CPM, in the triangle CPM. So CPM, this one you have to take it as a cos R. So cos R, you know that adjacent by hypotenuse. So ಏನು ಬರ್ತೈತಿ, ಸೊ PM divided by CP, PM divided by CP. So that one you have to take it as cos R equal to PM divided by CP, or so it CP take on this side, so CP into cos R. So but we know that CP, so this CP, so from here to here are equal. So here to here is T and plus T. So you got the CP is the 2T, C to P to C is the 2T. So CP equal to 2T. Therefore PM equal to CP dalli you have to put the value 2T cos R. So therefore X equal to, here we got the value X equal to NPM. So X equal to NPM equal to PM value is 2T cos R. So 2T cos R put here. We got X equal to 2NT cos R. This is the optical path difference. So now we have to study about the condition for maxima and minima. So when the condition for maxima, at that time the bright fringe will be formed. So the bright fringes, the path difference is, you have to take X equal to M lambda. Here M is you have to consider as a integer value when M equal to 0, 1, 2, 3 etc. So therefore 2NT cos R, this is the X value, already got the path difference, 2NT cos R equal to M lambda. This is M lambda. Okay, this is condition for maxima for bright fringe. Now condition for minima or dark fringes. So this condition for minima for dark fringes, the path difference already we discussed this one in the last, the interference in thin film due to reflected light. So X equal to 2M plus 1 lambda by 2. So X value we have to put, X value is 2NT cos R. So therefore 2NT cos R equal to 2M plus, this one is 2M plus lambda by 2. So where M equal to 0, 1, 2, 3 etc. the integer value. Okay, so next, now so here interference fringes are less distinct because the difference in amplitude between CR and EQ is large. Okay, so the fringes will be less distinct. It is very difficult to find out. So because the amplitude between CR and EQ, here CR and EQ is very large. So amplitude is very large, because of this the very distinct to find out. Okay, this is the concept of the interference in thin film due to transmitted light. Okay, thank you.